Hi, welcome back to the course ENSC 113 or the differential equation. So this time, say we have a dE which is x squared plus y squared d of x plus 2xy dy is equal to 0. Okay. Last time we've introduced to the one of the methods in order for us to solve for the differential equation. Solve for the solution of the differential equation. But as you can see here, we cannot use the separation of variables, or this equation is simply not separable. So we will now introduce another method in solving this kind of differential equations, and that is what we call the equation with homogeneous coefficients. So once again, if the given dE differential equation is not separable, maybe we can use another method, and by this time we will gonna investigate if we can adopt the equations with homogeneous coefficients or the homogeneous equations. Okay, so say we have this dE in form of some mixed function of x and y, d of x plus q as a function of both x and y also. Then like our equation, so this is this part here is the combination of our x and y dx, while this part here also is a function x y, combination of x and y. And as you can see here, if we try the separable equation, we cannot do it because we cannot separate x terms and y terms here. Okay, so if we have a similar problem like this, then maybe we can now try to figure out if this is a homogeneous equation. So how can we determine if the given function is homogeneous? So we have what we call the indicator lambda and its degree k. Say we have the function fy, and if this function is expressed in terms of the indicator lambda and produce the indicator lambda with the degree k, multiply to its function x and y, then if we can if we can express this and factor out this this indicator with its degree, then the said function is homogeneous. This is homogeneous. Okay, so for our example, the given example, say we have this as a given example. Say let us consider the functions. Say our function here, example, our function here is x squared plus y squared plus 2xy. Okay, so this is our function, and to determine if it is homogeneous, then we've tried to make the indicator lambda with x and y. So by doing that, we have uh, this is we will equate this x is equal to lambda x. So we have lambda x, and that is being squared, plus lambda y, that is also being squared, plus the indicator lambda x for the x and lambda y for the variable y. Okay, and by simplifying this, we have lambda squared x squared plus lambda squared y squared plus 2 lambda times lambda, we have lambda squared xy. Okay, and as you can see here, we can now factor out lambda squared or lambda with degree 2. So we can factor this out. So all in all, we have lambda squared x squared plus y squared plus 2xy. And since we can express this in a form like this, so we have lambda raised to k and then a function of x and y, then the said function is homogeneous. Okay, so this is our part here is the function of our xy. This part here is our lambda with the k, which is the degree. K degree. So this function here is called homogeneous of degree 2 in x and y. Okay, so let's try another example. Say we have another example. Say we have function is equal to 2x squared minus y squared plus 3x. Okay, then to check if this function is homogeneous, then we will apply the indicator lambda at x and lambda at y. Then by doing that, we have 2 lambda x squared minus lambda y squared plus 3 lambda x. So we have 2 lambda squared x squared minus lambda squared y squared plus 3 lambda x. And factoring this out, we have lambda squared, but this part here is only raised to 1, so we cannot purely factor out the lambda with some function of x and y here. That's why this given function here is not homogeneous. This is not homogeneous. Okay, so once again, say we have this kind of DE and we cannot do the separation of variable. Maybe we can adopt another method to find the solution of our DE by using homogeneous equation. But first, we need to figure out if really our given equation is homogeneous or not. So there is a technique wherein you need to add an indicator lambda to the x and lambda to the y variable. And by doing that, and after doing that, if you can factor out the lambda with its degree k designated by k, then the said function is homogeneous. Okay, so for example, we have this function, then we've tried to uh, uh, make the indicator lambda at x and y, then we substitute it to our function, and then we factor out the lambda with its degree k, which is equal to 2, then multiply by its function, and we come up with the similar form like this. Then this function is a homogeneous and the degree is 2. Okay, and for our last example, we've tried to figure out if this function here is homogeneous or not. That's why we take the indicator lambda at x and y, then we do the substitution, and we figure out that we cannot factor out the lambda, because here we have lambda with degree 2, here we have also the lambda with degree 2, but on our third part we have only lambda with degree 1. That's why we cannot completely factor out lambda out of the function. Okay, that's why this example function here is considered not homogeneous. Okay, so on the next video we will gonna discuss the steps on how to find the solution of the differential equation with a homogeneous coefficients. Okay, so see you on our next video.